Okay, kids, prepare to have your minds blown because lesson 6 is really interesting. And I don't know, I never really thought about this method of subtraction until I had to teach it. And I was like, what are they even talking about? It was crazy town for me. And since then, I've kind of learned to really appreciate it. So here it is, lesson 6, module 3. The objective is to subtract fractions from numbers between 1 and 2. And I hope your teachers, if you're not in my class, do the fluency activities from the teacher's manual. They are fantastic for building up your knowledge. It's basically like doing verbal math, like mental math. What's 1 minus 1/3? And then the students say 2/3. And so it's just putting parts together to make a whole. Anyway, speaking of the whole, WHOLE, that is what we are subtracting from today with our mixed numbers minus a fraction. And so, this looks all normal. We're going to make common denominators or like units so that we can do our subtraction. That's all great. Okay, so now instead of having thirds here and having halves here, we have sixths all the way across. So what is the big deal about today's lesson? All right, bear with me. This is it. Normally, we take the whole and we subtract the part. Easy peasy, okay? How many sixths do I have here? Well, I have 6 sixths plus the 2 sixths to make 8 sixths. And then you have your 8 sixths and you take away the 3 sixths and you get 5 sixths. So rest assured, if you can't figure out this fancy new way, you can just keep on doing what I call, it's a classic. You can keep doing it the classic way forever, and no one will ever know that you didn't want to do it this way, and that's okay. But for everybody else, if you are open-minded and willing to try to see this thing, it's not that hard. Method 2, the new way, is to look at the whole as being the 2 parts that it is. So instead of looking at it as 8 sixths, which it still is, look at it as 6 sixths and 2 sixths separately. And since I have 6 sixths, which is a really nice whole, this whole thing, I can just hold your horses here. Take the 3 sixths away from this one. Can't I do that? Well, of course I can. All I have to do is take 3 sixths away from something somewhere. It doesn't matter where it comes from. So if you take the 6 sixths and take this part away, that leaves you with 3 sixths left. Okay, so my answer to this minus this is this. But what about this? This is what I had in the beginning, 2 sixths. So what you do is you just put that right back through addition, and you end up with what the original classic answer is. That is today's new, weird, and awesome method. Okay, so splitting the whole is what we can do as we work our way through. Now, there are a couple of other problems. Now, this I actually have, it's kind of a crossed out, it's the same problem, but it's like I can take the 3 sixths from here, from the subtrahend, which I never really use those official words. I can take it and I can take it off of the 2 sixths here and here from one of the 6 sixths. So I'm taking the 3 off, which leaves me with 5. Okay, so I can get my answer this way, or going back to the new way, you can take the 3 off of the 6 and then just put this together so that you can see what's left. It's the same problem I just showed you in the other notebook, but it's kind of using this crossing out to show you where I am pulling from. Okay, so there are, this is another problem, kind of doing the first and the second way, or the classic and then the new way. So if I have 1 3/4 minus 4/5, then fourths and fifths would make 20ths. So we now have 20ths. And so you have 20 20ths and 15 20ths for a total of 35 20ths. So in the classic way, you take your total and you subtract your new equivalent to 4/5, which would be 16 20ths, and you just subtract 16 from 35. It's still just subtraction. And when you do that, you get 19 20ths. This is the classic way. Now the new way would be to take your 20 20ths, subtract 16 20ths from just that. Don't forget about this. That's probably the biggest tripping hazard of this type of method, is that you may forget to put this back. So do the subtraction. This is going to be easy subtraction. It leaves you with 4 20ths, and then just put that back. You get the same answer either way. So again, mind-blowing math today. That is what we're working on. So get those books out. Lesson 6. All right, let's get to it. For the following problems, draw a picture using the rectangular fraction model and write the answer and simplify if you can. All right, we have 1 and 1/4 minus 1/3. So this is going to require a full model and an extra one. Okay, and then we're going to subtract from that 1/3. So make a model for each one. And the first model is in fourths. So start separating into fourths. And it's all of one and 1/4 of the next. And then thirds on this one would be just 1 there. Now again, you cannot add or subtract unless you have like units. So take the thirds and lay them onto the fourths, and take the fourths and lay them onto the thirds, like so. And fourths. Oops, a little curvy there. That's okay. All right, so now I have 12ths. So let's do both ways. I want you guys to see this. Make a little space for yourself. Both ways. So if I have 12 12ths here, 13, 14, 15, I have 15 12ths as my whole. And then I'm going to take away 1, 2, 3, 4 12ths. Now 15 minus 4 is 11 12ths. And that's the classic way, is to put the whole together and then take this away. Now when looking at this one, the new way, okay, so jig, 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 and this is the or. You could take 12 12ths and take away 4 12ths from here to get 8 12ths. And then put back what we skipped here, 3 12ths, and 8 plus 3 is 11. And either way, we get 11 12ths. So I hope that makes sense to you. It's kind of exciting that there is something new in subtraction. And honestly, I don't even think I taught this way the first couple of years I was teaching it. I'm like, the old way is perfectly good. Why change the classic? But then I see this and I'm all, oh, I get it. And I should probably put up a video that tells you more about me, but I was an English major and I did not love math. So I would avoid it like the plague. Anyway, 1 and 1/5. Let's make more models. That's why I want to help you guys be better mathematicians than I was. So fifths, 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, minus, again, 1/3. That one's easy. Okay, all of this one, 1 and 1/5. Okay, now I cannot subtract if I don't have like units. So I need to take my fraction model, my area model, and make thirds on this one and fifths on this one. 1, 2, 3, 4, 5. Okay, now we know that we have 15ths here, so my whole is now 15ths. So how many 15 15ths? 16, 17, 18. We have 18 15ths, and then we have 5 15ths, and 18 minus 5 is 13, and that's my answer. And if you're happy with the classic way, then you can go on. But if you really want to try to learn the new way, you can take your 15 15ths and subtract the 5 15ths. That leaves you with 10 15ths, and then add on the 3 15ths that we left before, and you will get the same answer. So again, put it all together for this one and take away this, or just use this first one to take away the subtrahend, I think is what it's called. See, I will forget, I'll mix it up. But so use the whole and then take away this part and then put back when you get your answer. Oops, oh, somebody's gonna go, this is sadness. Fix that. Sorry about that, I hope it wasn't confusing. 10 15ths and then add the 3 15ths to get 13 15ths. 10 plus 3, 13, and that we don't change the denominator. We're talking about 15 parts. Okay, hopefully this is going well for you and you're not like tearing your hair out. 1 3/8 minus 1/2. Now with this 1 3/8 minus 1/2. The half is going to be really easy. I'm just going to start there. Now we have 1 3/8. So if we have eighths, it's 4 on each side, or 4 half. There we go. Oh, I can hear the janitor coming. Okay. There you go, all the eighths. Now this is the whole thing, 8 eighths, and 3 more. 1, 2, 3. Okay, so that is that's our eighths, but we need a common denominator. So I'm going to cut this in half, lay over the model from the previous one. Okay, now I have 16 pieces in each one. Okay, so I've got my 16 16ths, and then you have to add these. So the whole thing has 22 16ths. So add those all up, then take away the 8 16ths. Now if I subtract 8 from 22, I get 14 16ths. I know that's not simplest form, so I'll have to fix that in a few minutes. But let's do the second method. You can take your 16 16ths and take away 8 16ths. And that leaves you with 8 16ths, but you still have to put back these. So that makes 14 16ths. Now, when you don't have a simple answer, or both the top and the bottom are even, remember that you can divide both numbers by 2 to simplify. So 14 divided by 2 is 7, and 16 divided by 2 is 8. And so that's what I would do here as well, and that equals 7 eighths. And the next one is 1 2/5, so make 2 wholes of fifths, and then minus a half. There's your half. And fifths, 1 2 3 4 5. 1 2 3 4 5. All of this one. And 2/5. And then make the common denominator by making halves here and fifths here. Okay, so now instead of having fifths and halves, we have tenths. And so we have tenths. We know that's 5 tenths. And this is going to be 10 tenths plus 4 more. So I have 14 tenths. Now 14 minus 5 gives you 9, or you can do 10 tenths minus 5 tenths equals 5 tenths, and then add the 4 tenths that you had before to get 9 tenths, and that's simplest form. So I hope this is making sense for you. You don't have to do it both ways. You can just pick your favorite way and just do it that one way. I just really want you guys to see how it is done. Let's do another one. 1 2/7. Make your model. Minus 1/3. So 7. Make them small. 3, 4, 5, 6, 7. Kind of squished. And then 7/7 again. 1, 2, 3. Oh, there go the lights. 4, 5, 6, 7. And so add up all the sevenths. So I have 7 sevenths here. That's one whole, 7 sevenths, and 2 more. And when we add to get the whole, oops, I got to make my common denominator because we cannot work with thirds and sevenths. That would never do. Oop, 3, 1, 2, 3, 4, 6, 7. There we go. All right, now out of our 21sts, we have 7 21sts here, and then we have out of the 21, we have 21, 22 to 3 to 4 to 5 to 6, 27, and so you can subtract and get 20 21sts, or you can take your 21 21sts minus 7 21sts and get 14 21sts, and then add 6 21sts and end up with 20 21sts. Okay, either way. And finally, let's see, we've got 1 2/3. 1 2/3. All of 3/3. And then you can subtract from that. And we have fifths. 1 2 3 4 5. And then we have 3/5. 1 2 3. Hi, Pa.
Hi.
And so if you take your fifths and put them over 1 2 3 4 5, 1 2 3 4 5, and take your thirds and put them here, then we have 15ths minus 15ths, 3 6 9 15ths, and 15 6 7 8 21 22 23 24 25. Sorry, just I wanted to ask her something. Anyway, I'm distracted. Okay, so if I have my 25 15ths, I can do my straight subtraction, and so end up with 14 15ths. And, oh, sorry, not 14. 16 15ths. Good thing I thought about that for 1 second before I jumped onward to 15 15ths minus 9 15ths. And then the difference is 6 15ths, and put that back with the 10 15ths, and you get your 16 15ths. Okay, so I have 16 15ths both ways, but this is one of those awkward top-heavy fractions, and so you want it to work out 16 divided by 15. I can get that in there one time with 1 left over. And that is our simplest form. Okay? All right, so onward to the word problem. Jean-Luc jogged around the lake in 1 1/4 hour. William jogged the same distance in 5/6 of an hour. How much longer, ER, that's a comparative term, did Jean-Luc take than William? So what we need to do is we need to find the difference between 1 1/4 and 5/6. We're finding the difference. Okay, so use your fraction models. I have 1 1/4. Look at these crazy squares. They're like super crooked. 1 1/4 minus 5/6. Okay, in the middle, and then 3 on the top, 3 on the bottom. And it's all of them except 1. Okay, now can't work with fourths and sixths, but I want you guys to notice that 4 and 6 have a common denominator, and it is not just 24. 24 is a common denominator, but you can skip count, always start with the bigger number. 6 times 2 is 12. 4, 8, 12. When they have that in common, that can be your common denominator. So how do I make 12ths out of 6ths? I can simply cut it in half. How can I make 12ths out of 4ths? I can cut it into thirds. And so now I have 12ths on both sides. Okay, that's something that the book doesn't really go into. We talk about this later, but making the model, I'll say make the lowest common denominator model that you can, because you don't want to have 24 pieces if you can avoid it, or 36 or 72. It gets so busy, your work will get lost. You'll be like, I don't know, I can't figure it out. So anyway, I have 12 twelfths. Here, 13, 14, 15. So I have 15 twelfths total. That's my whole. And then I have 10 twelfths here. And so you can go ahead and do your straight subtraction. 15 minus 10 is 5. And so the difference, and again, you don't have to do it both ways. You could do it the other way if you wanted to, but we'll just leave this for now because I want to make sure we wrap this up. So it took 5/12 hour longer for JEAN-LUC. There you go. Okay, and there's only one more little problem, and it's top of the next. Okay, is it true that 1 2/3 minus 3/4 is equal to 1/4 plus 2/5? So you might look at this and go, what? How can this happen? But this is kind of that crazy new way. And so this is really proving if you understand this method, you can apply your knowledge on this problem. So take your 1 2/5 and make a model. Try to do better this time. 1 2 3 4 5. 1 2 3 4 5 minus 3/4, half, top half, bottom half. 3/4, shade, shade. And then all of these 5/5 and 2 more. Okay, now this, we're going to use the new method because that's what they're asking us. They're saying, hey, do you understand the new method? So put your 4ths over the 5ths, half the top, half the bottom, and put your 5ths over the 4ths, 1 2 3 4 5. And so we have now created 20ths. Okay, so we're going to have 20 20ths. And 2, 4, 6, 8 20ths. Okay, now these are our splitting the whole. Okay, from one of these, I'm going to take my 15 20ths. So where does all this stuff come in? If I was to take my 20 minus 15, I would get 5/20. And if I had 5/20, and then I add, again, this 8/20, then I have my addition problem that they're talking about. But the straw that broke the camel's back, the part that you guys are like, I still don't get it. It's okay. We're going to simplify these. So if I could change the look of both of these fractions by recognizing that they both have simpler forms, that is where we're going to get this. So what can I divide both of these numbers by so that I could simplify this fraction? Well, I could divide both by 5. So if I divide 5 by 5, I get 1, and 20 by 5, I get 4. And then if I look at this, well, I can't divide by 5. That's okay. I don't have to. Every fraction is its own unit. And so when I look at these two numbers, how are these two numbers related? They're related by 4. So divide 8 by 4 and get 2, and divide 20 by 4 and get 5. And now I have the same thing that they are suggesting. So is it true that this can equal this? And the answer is yes. And so this is the proof right here as you show your work. So crazy lesson. I know it's really wild, but I hope this was helpful. If it's helpful and you like these, click subscribe, and I'll try to do some more good lessons for you. I hope they're helpful. You guys take care. Have a great day.